Hi friends, welcome to our lesson. I'm Mrs. Gradney, and today we'll be multiplying two-digit multiples of 10 by two-digit multiples of 10 using the area model. Here's what you'll need for our lesson. Let's get started. Let's read this expression together. 30 times 20. Here, we're multiplying a two-digit number by another two-digit number. What are some other ways we could express 30 times 20? I heard someone say we could write 3 tens times 2 tens, so express it in unit form. Or we could decompose the factors. We could express it as 10 times 3 times 20, so we decomposed the 30 into 10 times 3. Or we could decompose the 20, and we could write 30 times 10 times 2. Or we could express it as 10 times 20 times 3. Let's use 10 times 20 times 3 in the place value chart to help us solve 30 times 20. And I'll erase these other ones down here. We can interpret this expression as 10 groups of 20 times 3. So we'll start by drawing 2 tens, which is 20. What is 2 tens times 10? 2 tens times 10 is 2 hundredths. So 10 times 20 is 200. And how would we represent 200 times 3? We could triple this group. So we could draw 2 more groups of 2 hundredths, which equals how many hundredths? 6 hundredths. So 200 times 3 equals 600. So what is 30 times 20? 30 times 20 equals 600. Now let's erase. And let's try another way. Let's try 10 times 30 times 2. We can interpret this expression as 10 groups of 30 times 2. Pause the video and represent this expression in your place value chart. Then come back and we'll compare. Here's how I represented it. We can think of it like this. Here's 30, or 3 tens. 10 times 3 tens is 3 hundredths, and 3 hundredths times 2 is 6 hundredths. How does this product compare to the last one we got? They're the same. Let's try another way. Here are 2 different ways we can express 30 times 20. 2 times 30 times 10, which we can interpret as 2 groups of 30 times 10, and 3 times 20 times 10, which we can interpret as 3 groups of 20 times 10. What do you think the product will be to either of these expressions? Make a prediction. Now, choose one of the expressions and pause the video and represent it in your place value chart. Or if you'd like to represent both expressions in your place value chart, you can do that as well. Then come back and we'll compare. So what did you get? Here I've represented both expressions, and either way we get 6 hundredths again. When we multiply a two-digit number by another two-digit number, there are many equivalent ways to express it as a product. And decomposing our multiplication problem into more units can help us solve. Let's try another problem, this time using unit form to think about it. Let's read this expression together. 40 times 20. Now, say the multiplication expression in unit form. 4 tens times 2 tens. What do we know that can help us solve? You may be thinking that we know 4 times 2 equals 8, but then what about the tens? What do we need to do with those? Pause the video to think about what we might do with the tens, and then come back and we'll talk about it. Some of you may have been thinking that 4 tens times 2 tens equals 8 tens, but we still need to multiply the tens. 10 times 10 equals 10 tens, or 100, not 110. So tens times tens gives us a new unit of hundreds. So 4 tens times 2 tens equals 8 hundreds. Are you still not sure? Let's use an area model to prove that when we multiply tens times tens, we get a new unit of hundreds. Let's draw a 40 by 20 rectangle on our personal whiteboards. And we'll partition the vertical side into 4 tens. We'll try to make them as equal as we can, but they don't have to be perfect. And we'll partition the horizontal side into 2 tens. And let's label all of our tens. Now, how can we find the area of 1 square? We know area equals length times width. So for 1 square, the length and the width are both 10. 10 times 10 equals 100. For this square, 10 times 10 equals 100. So each of these squares has a value of 100. What's a multiplication sentence for how many squares there are? 4 times 2 equals 8. And since each square has a value of 100, that's 8 hundredths. How does this rectangle prove that 4 tens times 2 tens equals 8 hundredths? Pause the video to reflect and talk out your thinking. I was thinking that each square is 10 by 10, which is 100. And there are 8 squares, so that's 8 hundredths. Let's try another one. 50 times 40. Say the expression in unit form. 5 tens times 4 tens. Now pause the video and draw a rectangle to represent 5 tens times 4 tens and solve. Then come back when you're done and we'll discuss. Welcome back. Here are 2 different ways you could have drawn an area model to represent 5 tens times 4 tens. Which one shows how you thought about it? In this first area model, we can clearly see that 5 times 4 equals 20 because we can see 20 squares. So then we think 20 what? What's the unit? Well, each of these squares has a value of 100, so that's 20 hundredths. And 20 hundredths equals 2,000. So 50 times 40 equals what? 2,000. Let's try another problem. 60 times 30. Pause the video and solve the problem. If it's helpful for you, you can use an area model and explain the strategy that you're using out loud. Then come back and we'll discuss. Welcome back. Did you find that 60 times 30 equals 1,800? On the screen are 2 different ways that you may have thought about it. In the first way, we used unit form. 60 was renamed as 6 tens and 30 was renamed as 3 tens. Then we multiplied the number of units. 6 times 3 is 18 of some unit. Then we think tens times tens gives us hundreds. So 6 tens times 3 tens equals 18 hundreds, or 1,800. In the second way, each factor was decomposed. 60 was decomposed into 6 times 10, and 30 was decomposed into 3 times 10. Then we can multiply in whatever order makes it easiest for us. So 6 times 3 equals 18, and 10 times 10 equals 100, and 18 times 100 equals 1800s, or 1,800. So what conclusion can you make about multiplying a unit of 10 times a unit of 10? You may have been thinking that 10 times 10 is always 100. We can decompose any unit of 10, multiply the number of units there are, and then the product will be that many hundreds. Excellent work today, friends. I think we're ready for the problem set. On the screen are the must-do problems for the problem set. Set a timer or watch the clock for 10 minutes and work on these problems. Of course, if you still have extra time, feel free to work on any of the other problems on the problem set as well. Today, we multiplied 2-digit multiples of 10 by 2-digit multiples of 10 using an area model. Remember to check in with your teacher, and I'll see you next time for another Eureka Math lesson. Bye!